All right, what's up? We got more free response problems to do. We're going to do the table problems. We got 9, I think, to do. So let's get started with the 2019 number 2. So 2019 number two is a calculator problem. The thing about table problems is that there's a table, but the question could be rate, could be straight line motion, could be just a function analysis, could be anything. So um, it's got a table, but then like the stuff in the table, who knows what it is. Okay, in this one we have velocity. So this is like the straight line motion table problem. So velocity of p, particles at the origin at time t equals 0, so that's the initial position. X of 0 is 0. Just find why there must be at least one time t from 0.3 to 2.8, in which v prime of t, which they tell you is the acceleration, that's nice, equals 0 meters per hour per hour. Well, this is a mean value theorem problem. You have to first comment to use the mean value theorem that the function is differentiable. So v of p is differentiable. And the average rate of change from 0.3 to 2.8 is 55 minus 55 over 2.8 minus 0.3, which is 0. Therefore, by the mean value theorem, there must be a time t between 0.3 and 2.8, which v prime of t equals 0. Remember mean value theorem, if your function is differentiable between 2 points, it's connected in a smooth manner, the secant slope between the 2 points, there must be a tangent slope that equals that secant slope. For our situation here, the secant slope is 0 because we have the y coordinates of 55. The velocity is 55, 55. So there must be some time where the tangent slope is 0. Okay. Use a trapezoidal sum with 3 subintervals to approximate the value integral from 0 to 2.8 via p t dt. They don't even ask you like, what does this mean? Usually they'll say like, calculate this and then tell me what it means, interpret it. So I'm going to interpret it for you. This is displacement of the particle from 0 to 2.8. Now, how do we do a trapezoidal sum? We'll figure out the base lengths, understand the heights you're using, and then the formula is 1/2 base times the sum of the heights. So I got a base length of 0.3, a base length of 1.4. I got a base length of 1.1, and a base length of 1.2. So the formula I would write down 1/2 0.30 plus 55 plus 1/2 1.4, 55 plus negative 29 plus 1/2 1.1, negative 29 and 55 plus 1/2 1.2, 55 and 48. Now, for a non-calculator question, you can leave this. This is like a calculator ready form. This is the answer. But since you are given your calculator, they kind of expect you to find the value. So it's not going to take us that long to just type this data in. So there's my first trapezoid, my second. There are ways to like factor out the 0.5 if you wanted to. But whatever. Times. Why does it not do 2 Fox when I click twice? Okay, and I get 141.8. I should be zoomed in on this. That'll be easier. C, a second particle Q also moves along the x-axis, so the velocity is given by this. Find the time interval during which the velocity of the particle Q is at least 60 miles per hour. Find the distance traveled by the particle Q during the interval when the velocity of particle Q is at least 60 miles per hour. So I got to figure out the time interval in which the velocity of Q is 60 and is greater than 60. It's really greater than or equal to 60. So I'm going to graph the velocity of Q and 60, and I'm going to look at it, and I'm going to find the intersections. 45 root t cosine 0.063 t squared, 60. You could also graph this in 0, like v of q minus 60 equals 0. That's fine. I'm going to adjust my window so that I can see 60. And we're going from 0 to 4 on our time axis, which is our x-axis in this case. So there's my velocity. Here comes my 60. I got to intersect at this 1.88 number. I'm going to write the whole thing down. A little shortcut you can do is like that number saved. You can store this as like A. Maybe you say that's A. Why do I do that? I'll show you in a second. When I find the second number, which is 3.519, 1744. I'm going to store that as B. So now that's stored as X. I'm going to store that number as B. Now distance, you know that it's the absolute value of velocity, but since velocity is positive on this interval from A to B, and I can write this just to make a little shortcut. Since I know velocity is positive, I don't actually need to use the absolute value. I'll show you really quickly. Math 9, A to B of the absolute value. And if you don't use A and B, you have to type in this entire number. Don't round it. The velocity of Q is 45 root t cosine 0.063 t squared. Okay, and you get 106.108. Watch, if I do the same thing, but I delete the absolute value, I'm going to get the same value. It's because the velocity is not negative. The velocity is positive. It's bigger than 60. I delete the absolute value, I get the same number. Okay. When velocity is positive, distance and displacement are the same. It's when velocity is negative, that's when displacement and distance are going to differ. Okay. At time 0, the particle Q is at position -90. Use the result from part B and the function v of Q from part C to approximate the distance between the particles P and Q at time 2.8. Okay. Ooh, hold the phone. Oh man, look at what they just did. They screwed me up. 0 to 2.8. I should not have this. I just need the first 3. So let's actually go back. I made a mistake. Go back to your trapezoidal Riemann sum calculation. Let's delete this last piece. 80. Look at that. Um, well, to figure out the distance between P and Q, I have to look at their two positions. Okay? It's a calculator problem. What's the formula that we always use for a calculator section? An unknown equals a known plus the displacement, which is the area under the derivative of position and velocity. So here for Q, particle Q at time 2.8 equals my original position at negative 90 plus my displacement from 0 to 2.8. I'm going to do that. I get 45.937. So that's my position of particle Q. Now, my position of particle P at 2.8 is, again, same equation, but I start at an initial position of 0, and then I'm going to use my approximation of my displacement, which I found from part B is 80. So Q is at 45.937, P is at 80. What's the distance between them? Subtract the 2. Right minus left, like top minus bottom. That's how you find distance between two things. You take the positions and subtract them. You get 34.063. Let's check out the scoring guidelines for this one. So AB 2019 scoring guidelines. Let's see how we did. All right, part A was 2 points. Understanding that the velocity or the secant slope was 0, the justification using the mean value theorem, making sure that you know that the function is differentiable. Boom, you're good. So that's 2 points. For 2 for 2. Trapezoidal sum is 80. What did I mess up with? 40.75. That's going to screw up all my answers. What did I make a mistake with? Right there. Gosh, right off the bat. That's not even right. 1.5.3, 0.55. 1/2. 1.4. Oh yeah, I was like saying, like, why does it not show up the 55 when I click it twice? All right, this just shows you got to be careful out there, guys. Even I'm making mistakes just typing things in a calculator. There's that 40.75. So that's going to change my last answer. Let's go fix that. 5.187 is the distance between the two. Well, let's see if I screwed up on anything else. All right. Trapezoidal sum answer, you get 1 point for there. Part C, you get 3 points. 106.109. 106.109, boom, we got that right. So you would get points for your interval, finding the intersections, points for using a definite integral, and then getting the correct answer. Part D, 0 to 2 point of v of q would have gotten you points, but then adding the initial position, which is the position of particle q, that gets you the second point. Subtracting the two, 5.187 meters apart gives you the third point. Okay, not that bad. Just don't mess up on the trapezoidal sum. I would have gotten full 3 points though for part D because I used an incorrect answer correctly. They will not punish me for doing something wrong, making a mistake earlier, but then using that correctly later. So just know that. All right. All right, next question is 2018 number 4. Let's close this one out. So since it's a number 4, it's a no calculator question. I'll show you how with no calculator questions, especially the trapezoidal Riemann sums, you don't have to waste time doing arithmetic. Okay. All right. Now in this situation, we're given the height. It's not a derivative. It's just the height of the tree. So if I take the derivative, I will find the rate of change of the height of t. How quickly is the tree growing? So use the data in the table to estimate h prime of 6. Well, 6 is between 5 and 7. A derivative is just a slope. The best way to approximate the exact slope of 6 is to use the secant slope between 5 and 7. So h prime of 6 is approximately 11 minus 6 over 7 minus 5, which is 5 over 2, 5 halves. The tree is growing at 5 halves. What did I do? Meters in the top, years on the bottom, meters per year. Okay, you got to make sure if they ask you for units, you provide units. Explain why there must be at least one time t from 2 to 10, such that h prime is t is 2. Look at another mean value theorem problem. Some constant questions that are asked from tables are approximating slopes and mean value theorem. So from 2 to 10, we're looking for a slope that's 2. But like, if I look at the slope between 2 and 10, I'm not going to get 2. It's like, that's not 2. So it's like, wait, that's not the mean value theorem. But look a little harder. Look right here from 3 to 5. 6 minus 2, that's 4. 5 minus 3, that's 2. 4 divided by 2 is 2. Actually, we needed to look inside our data to find an average rate of change that equals the slope we're looking for. Okay? Boom, that's 2. So what does that mean? Since h is differentiable, and the average rate of change from 3 to 5 is 2 by the mean value theorem, there must be an h prime that equals 2 for a t value, not only between 2 and 10, but between 3 and 5. Okay? Use a trapezoidal sum with 4 subintervals indicated by the data to approximate the average height of the tree. Okay, guys, if you're just doing a trapezoidal sum and you get your answer, you're not going to get the answer correct because average height of a tree, 1 over b minus a, integral from a to b of what you're trying to find the average of. So you need, and I'm going to just show your work down here, part C, 1/8 times, here we go, my approximation. I'm going for 2 to 10, so I'm including all the data. So I got 1, 1.5, and 2. Then I got 1/2, 2, 3 to 5 is 2, 2 and 6. Then 1/2, 2 again, 6 and 11. And then my last one, 1/2, 3, 11 and 15. Now, this would take me a long time to do the arithmetic for. Long time. You're done. You don't have to do the arithmetic. You don't have to do the calculation. They're going to show you what the answer is. And we could use our calculator to find it. But since it's a no calculator question, this is what's called a calculator ready form. You may leave this like that. Okay? Now let's go to the tricky part, part D. The height of the tree can also be modeled by this. So this is a function that can model my data, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? Okay, so x is the diameter when the tree is 50 meters tall. Well, the height of the tree is given by g. So when g is 50, the diameter is increasing at a rate of 0.03 meters per year. Increasing at a rate per year. This is a related rate question. This is a DDT. dx dt would be the rate at which the diameter is increasing. That's 0.03. What is the rate of change of the height of the tree? So that's dg dt is what we're trying to find when g is 50. That means I got to take g, which is 100x over 1 plus x, and take the derivative of this with respect to t. Now, this is tricky because it's like x's. Usually when students take the derivative of x's, they don't think of d blank dt. But we need to include a d blank dt. All right, so I get dg dt equals, I have to use the quotient rule. The derivative of the top is 100 dx dt times the bottom, 1 plus x. Minus the derivative of the bottom is dx dt times the top, 100x. All over the bottom squared, that's 1 plus x squared. Now we have a problem. What the heck is x? Right? You don't give me x, they give me g. Well, guess what? This is like the whole extra step on the related rates problem. We need to find x when g is 50. Multiply by 1 plus x, I get 50 plus 50x equals 100x. I subtract 50x, I get 50 equals 50x. I get x equals 1. So here's how I'm going to find dg dt. I have 100 times 0.03, which is dx dt, times 1 plus 1, which is 2. I got that 1 from solving. Minus dx dt, another 0.03. 100 times x, that's 100. All over 1 plus 1 squared, so that's 2 squared, so that's 4. And once again, leave this. Leave this. This is done. This is your dg dt. This is a no calculator question. This is a calculus test, not an arithmetic test. Okay? Let's see how we did. All right. Part 1, the 5 halves. you got 1 point for the estimate, 1 point with the interpretation of the units. H prime is the rate at which the height is changing in meters per year at that time. So we got that. I should have said at t equals 6. Part B, you need to talk about the function being differentiable. You need to use the mean value theorem. You need to define the slope between 3 and 5 was 2. That was worth 1 point. And then reference the mean value theorem after talking about the function being differentiable. Part C, you get 1 point for the correct trapezoidal Riemann sum. Look at this. Look at this fraction. Don't spend time finding that. That's ridiculous. But you get 1 point for having the 1/8 and then all of this work. We had the 1/8, all of the work. I'm done. I'm not going to bother doing the work. Okay. Part D, 3 points. 2 points for taking the derivative of g correctly to get dg dt equals 100 dx dt. They just multiply by ddx dt afterwards. Dx dt is factored into ours, which is fine. You end up with 3/4. I'll show you how that's 3/4. But like they won't expect you to get this answer by hand. It's unrealistic. There you go. Okay. All right, next problem. 2017 number 1. Back to being a calculator question. And what do we got? The tank has a height. The area. This is a tricky problem. This is another kind of like almost like a curveball, but using a table. The area of the horizontal cross section of the tank is given by the function A. These are areas of a tank. So the tank is like maybe like conical in its shape, where like at the bottom, the area on the bottom is larger than the area at the top. Selected values. Use a left Riemann sum with the 3 subintegrals indicated by the data to approximate the volume of the tank. They're pretty much helping you out, like telling you that if you take the area of A of H, it ends up being DH from 0 to 10. What you're doing is you're doing square feet times feet, and you get cubic feet. So infinite sum of areas, just kind of like our volumes of objects with known cross section. When you take an infinite sum of the areas, you end up getting a volume, so long as you're talking about like having a very, very skinny like width at that area to get a volume. So they're kind of just telling you that. Indicates units of measure. They're telling you it's a volume. Maybe you didn't know this. Maybe you didn't know feet squared times feet cubed, but it's like they're telling you it's volume. So that should help you. So we just need to approximate 0 to 10 of A of H dH. So left Riemann sum. Base times left height. Base times left height. Base times left height. So 2 times 50.3 plus 3 times 14.4 plus 5 times 6.5. We'll find that value because we have our calculator. It's in cubic feet. Hope I typed that in right. 176.3 cubic feet. Does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. Oh man, left Riemann sums. Well, function A is decreasing. You need to look at this opening paragraph. They're going to give you what you need to answer this question correctly. Since A is a decreasing function and you're using a left Riemann sum, a left Riemann sum for a decreasing function is always over. You literally can just say it's over because A of H is decreasing. The area of a horizontal cross section at height 8 is modeled by the function given. So this is modeling this data. Based on this model, find the volume of the tank. I mean, they kind of just told you what to do earlier. It's like, hey, take an integral of areas to get volumes. Okay, so like that's what we're going to do for part C. We're going to take an integral from 0 to 10 of f of h, and that will give me the exact volume of this tank, provided that this is the exact function. It's like this seems like a tough question, but they actually help you out a lot. There's some questions out there where like they won't give you hints as like here guys, this is what you got to do. I know some of my students just freaked out when they saw this problem, but just like take your time, breathe, and uh, and read, and maybe you're going to get some help. Oh, 101.325. So like, yeah, that was an over approximation, 176. All right, part D. Water is pumped into the tank. When the height of the water is 5 feet, the height is increased. Oh, look, at a rate 0.26 foot per minute. Look at that. We have a related rates problem, d dt. When h is 5, height is increasing, dh dt equals 0.26. Find the rate at which the volume of the water is changing with respect to time on the height of the water. Ooh. Find the rate of change of the volume of the water, not the rate of change of the area. Okay, well, the volume of the water. This is okay. This is tricky. The volume of the water is this infinite sum from 0 to some time of f of h dh, right? We just took an integral to find a volume, okay? Now, for a specific time, 0 to 10. Now, ready? Take the derivative of this. I get dv dt equals. I know we say this is f of t, but watch what happens. Like, take the antiderivative. Plug in 0 and plug in t. Take the derivative of that with respect to t. I feel, boy, this is, I feel like I need a dh dt, but I'm kind of confused as to why. I don't know if we need a dh dt. We need to figure out what t is when h is 5. Listen, I'm going to assume I don't have a dh dt, because if I evaluate it, I'd take the antiderivative, which is big F of h. I plug in 0 and t. I get big F of t minus big F of 0. I take the derivative of that, and I get big F of regular F of t. dv dt is just the rate, the change in the volume ends up being what my area is at that moment. That's kind of tricky to think about and visualize, but I'm pretty sure that's the answer. All I need is to find the time when my height is 5. I don't think I need dh dt. I could be wrong though. Let's see. I'm gonna go back to Zoom standard. Though it should be from 0 to 10. So there's my area. Here's 5. My time is 6.436. I think that dv dt is f at 6.436. Let's find out. It's Mr. Messner. Hey, how are you? I'm good, man. It's good to hear you. She's leaving. Yeah, Reyes is leaving. Reagan's going to leave. Kelsey hires. Lindsey Reagan's going to leave. Kelsey Hire is going to leave. Jorge might leave. That's it. We have made 2 hires, and then of course the Pickens slash Powers left. Okay. Uh, one called Brevard. She's been like a principal slash like instructional coach for years and years and years. And oh, geez. All right. So where were we? We're about to plug in 6.436, which I hope was saved as X. Yep, saved as X. So if I do 50.3 divided by e to the x, 0.2x plus x, I hope to get the answer 5. I think dv dt is 5. Let's find out. 2017 free response guidelines. Which one is this? 1. Oh, they wanted times dh dt. 0 to h. Damn. I guess it is based on h. All right, well, let's see. Did I mess up on anything else? 176.3. Okay, left Riemann sum. Boom, cubic feet. Overestimate because A is decreasing. Boom. 101.325. Boom. Yeah, I messed up. V of H is 0 to H of F of something else. Yeah, because 10 is not T. It's 0 to 10. Oh, gosh. They said like 0 to H of, this F function, which means dv dt is f of h times the derivative of h dh dt. So it's 5 times 0.26. Oh, it's f of 5 times 0.26. It's not a time. I messed up. I'm sorry. This is garbage by me. But I don't know. Like if Mr. Messner can't do it, I can't do it. Yeah, what was I thinking? H is 5. That's H. H is 5 times dh dt. There's some questions that are really tough. I bet you some of you could have gotten that right if you just thought more like I didn't. I'm trying to just race through these and get them done. Yeah, it's on the right track. Okay, next problem. (2016) number 1 and number 6. All right, it's a rate problem with a table. We'll probably do this in class because it like reviews rates. We got pumped into the tank at W of T, removed at a rate of R of T. So this is a rate problem, but it's got table stuff in it. At time t, there was 50,000 liters of water in the tank. That's like our total at time 0. R prime of t. So R prime of 2. 2 is between 1 and 3. The best way to approximate it is to use the slope of the secant. So 950 minus 1190 over 3 minus 1. That is liters per hour divided by hours. That's liters per hour squared. Remember, R is a rate. It's a derivative. It's a first derivative. So that means it's a velocity, which means its derivative would be an acceleration. That is one way to like do units of measure. Derivatives of velocities or accelerations per hour squared versus maybe this, you could do liters per hour divided by hours, liters per hour squared. 950 minus 1190. Divided by 2, because it's 3 minus 1. I get negative 120 liters per hour squared. Left Riemann sum, indicate by the table to estimate the total amount of water removed. So remember, just like the formula, the total amount is equal to our initial amount plus our total in, which will be an integral of our rate in pumped into the tank is W, and then integral of our rate out is R, which will be the total out. So we're going to approximate the total out. So integral from 0 to 8 of R. We got a left Riemann sum, so base times left heights. So that's 1 times left height. This is a base length of 2 left height, 3 left height, 2 left height. So 1 by 1340 plus 2 by 1190 plus 3 by 950 plus 2 by 740. And let's do those calculations. $80.50. Okay, so that's an approximation of the total amount removed over or underestimated the total. R is decreasing. It's just like the last problem. Decreasing functions using a left Riemann sum, overestimate. It's an overestimate because R of t is decreasing. Part C, use your answer from part B to estimate the total amount of water at time 8. Total amount of water at time 8 is equal to the initial amount of water, 50,000, plus the total that has been pumped in, integral of our rate in, minus the total that is pumped out. We just approximated that. That was 80.50. Let's do the calculation. If you ever get like a negative number, you should know you did something wrong. 49,786 to the nearest liter at the end of 8 hours. To the nearest liter. Yeah. Part D, is there a time when the rate at which the water pumped into the tank is the same as the rate at which the water is removed from the tank? Okay, so is there a time when there's like a max or min? Explain why or why not. Well, like, you see R values go from 1340 and it's decreasing down to 700. Let's look at W values. I could either graph W or I could like literally just plug in 0 and 8 into W. But it's probably best to look at it. and to talk about its characteristics, be like, oh, this function is increasing the entire time, or this function is decreasing the entire time. I'm going to have to adjust my window probably to be pretty significant. Yeah, look at that. Okay, so you can say W of t is decreasing. If you want to be like particular about it, you can say W prime is negative on the interval from 0 to 8. Okay. Now, it starts at 2000. W of 0 is 2000. W of 8 equals 81.52. Might as well use the third decimal. 524. Okay. This starts as 1340 and ends at 700. R of 0 is 1340. R of 8 is 700. Since both W and R are decreasing, W going from 2081, R from 1340 to 700, they will be continuously decreasing. W is going to have to cross through R, which will be decreasing at a slower rate at some point. Don't try to find the point. Literally, if you just write these values and say they're both decreasing, you could say there must be a time where W equals R. Decreasing, and you could say they're continuous. So the graph probably won't give you any points, but you could say this is W from 2000 to 81 versus this is R from 1340 to 700. They'll have to intersect somewhere. All right, let's see how we did. This is 2016. Number 1. Negative 120 liters per hour squared. Estimate units, 2 points. Left Riemann sum, estimate, overestimate with reason. 80/50, which gives us the 2 points, overestimate because R is decreasing. Boom. C, 49786. 49786, 2 points. D, considers W minus R or W equaling R. Answer with explanation. They invoke the intermediate value theorem. My explanation's fine. Functions are continuous, and we got this going there, that going there. My answer is fine too. Okay, and then apparently there's another one in this. Number 6. Oh, this is a great one. This shows you like maybe tables aren't like what we used to. Maybe this is not like a Riemann sum. This is just an A, B, and C, and you got FF prime, GG prime. Like, what's this going to look like? Well, it says write an equation for the tangent line to the graph of K at x equals 3. Okay, all right. I guess I need, for part A, a y minus y1 equals an m times an x minus x1. X is 3, so I need K of 3. This is 3, and I need K prime of 3, right? All right, well, what's K of 3? K of 3 is f of g of 3. G of 3 is 6. F of 6 is 4. So I got y minus 4 equals some slope x minus 3. Let's find K prime. The composition, O's and I's. If you weren't ready for that for the multiple choice, hopefully this will get you ready for it. It's not a product. This is a composition. The derivative of k of x, f prime of g of x times g prime of x. K prime at 3 is what we're trying to find, is f prime of g of 3 times g prime of 3. G of 3 is 6. F prime of 6 is 5. G prime of 3 is 2. 5 times 2 is 10. Leave it. You don't have to solve for y. What's h prime of 1? Take the derivative of this. Well, quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. G prime of 1, 8. F of 1, negative 6, minus f prime of 1, 3. G of 1, 2. F of 1, negative 6 squared. Don't waste any time doing calculations. You could literally leave it like this. Okay? Evaluate integral from 1 to 3 of f double prime of 2x. Okay. It's the area under f double prime. I don't have a function. I can't use my calculator. I can't use Riemann. Use Newton. Let's take the antiderivative. The antiderivative of f double prime would be f prime of 2x. But hold on. Because of 2x, I need a 1/2. Not a 2, a 1/2. Like, think about the derivative of this using the chain rule. It'd be f of 2x times 2. The 2 times the 1/2 would go away. So this is it. Plus a c, but you don't care about it, from 1 to 3. That gives me 1/2 f prime of 6 minus 1/2 f prime of 2. F prime of 6 is 5. F prime of 2 is negative 2. So I got 5/2 minus negative 1. Right, f prime of 2 is negative 2. So that's positive 1. That was right. Negative 2 times a half is negative 1 minus positive 1. So 7/2. All right, let's see how we did on that one. This is 9 points, guys. 3 points, 3 points, 3 points. The slope being 10. The equation for the tangent line. They solve for y. You do not have to solve for y. This is fine. Y minus 4, 10, x minus 3. Negative 3/2, which they got from 8 times negative 6 minus 3 times 2 over negative 6 squared. Boom. That's fine. They'll accept this. 3 points. Expression for the derivative is 2 points. The antiderivative is 2 points. 1/2 f prime of 2x. 1/2 f prime of 2x. 7/2. 3 points, 3 points, 3 points. That's not bad. All right. Let's go to the next problem. 2015, number 3. I don't think I'm going to finish these. 2015, number 3. Velocity. This is a straight line motion problem using a table. These are going to be like the first 2 problems that we do. It's like what we just learned last class, a straight line motion and a rate, but now using a table just to get us incorporated the table. Joanna's jogging. What's V prime of 16? 16 is smack dab between 12 and 20. The best approximation would be the average rate of change. They don't even ask you for units, but the units would be meters per minute squared. It's an acceleration. 40. This is question number 3, so you can't use your calculator. You would just go 40 over 8. And if you simplify, good for you, but you don't have to. Divide by 4, 10 over 2. Wait, that's 40 divided by 8 is 5. Ha. This is meters per minute squared. Using correct units, explain the meaning of the definite integral 0 to 40 of v. Approximate the value. Okay, distance from 0 to 40 of Joanna in meters. Distance is like a length. It's meters. It's not meters per second, just meters. Now, what do you have to do? Write Riemann sum, but make sure all your velocities are positive. So, your right Riemann sum would be 0 to 12, 200. That's 12. 12 to 20, that's 8. Use 240. 20 to 24, that's 4. Use positive 220. 4 to 40, that's 16. Use 150. Okay, now don't spend time doing any arithmetic. If anybody's spending any time doing arithmetic, then you're not paying attention to what I say during class. Okay, leave it. Positive 220. If this was negative, then you'd have a displacement. Bob is riding his bicycle. Bob's velocity is this. Find Bob's acceleration at t equals 5. Well, if Bob's velocity is b, Bob's acceleration is b prime. And Bob's acceleration at 5 is 3 times 25, which is 75, minus 12 times 5, which is 60, 15 meters per minute, I tell you. Based on the model from part B, find Bob's average velocity. Average, 1 over b minus a, integral from a to b of what we're trying to find the average of. Velocity. Bob's velocity goes in here. How do you find an integral without the use of a calculator? Newton. Newton helps us. Says change in antiderivatives gives us areas under functions, Area under a derivative is a change in total. That's what he tells us. 2t cubed plus 300t plus c, I don't care about it because it'll go away when I subtract. 1/10, 1/4, 100 to the 4th. Sorry, 10 to the 4th. Don't waste your time doing this. Don't waste your time doing this math. You can divide everything by 10 and get 1/4 10 cubed minus 2 10 squared plus 300. But I don't care. All right, this is 2015. Number 3. 5 meters per minute squared. I don't think they asked for the units, so just 5 is fine. Distance. 3 points. 12, 200, 8, 240, 4, 220, 16, 150. Don't waste time to get that value. They will accept this as your answer. I know you don't believe me, but you gotta believe me. 15 I got. Boom. Uses B prime, getting the answer. Look at that. T to the 4th over 4 minus 2t cubed plus 300t. Plugging in the value, leaving it. Perfect. Okay. They didn't even do simplification, which is this is yeah, this is perfect. Okay, but this ends up, if you calculate it, will be 350. Your integral, your antiderivative, your answer. 3 points. All right, let's do another one. 2014, number 5. I think I might stop here. If this is all I can do in this time, then you guys would take longer to do these. This is really a function analysis one. Let's go to 2013. 3. The computer gets really slow when it's recording. Okay. will be the last one. All right. Hot water is dripping through the coffee maker. The amount of coffee in the cup is given by C. C is a total. It's not a derivative. Okay? It is how much we have. Not a derivative. This is f of x, not f prime of x. This is x, not v. Use the data to approximate C prime of 3. Indicate units per measure. This would be an approximation of the velocity of the derivative. It would be the ounces per minute. 3.5 is smack dab between 3 and 4. This is number 3, so it's a non-calculator question. 12.8 minus 11.2 over 4 minus 3. That's 1.6 ounces per minute. Is there a time between 2 and 4 which C prime is 2? Mean value theorem, 2 and 4. Let's see. I'm not going to write all the things out, but you're told that the function is differentiable. You can use the mean value theorem. Mean value theorem says there must be a tangent slope that equals the secant slope over your interval. Secant slope is the average rate of change. 12.8 minus 8.8 over 4 minus 2 equals 2. I'll just say it. There must be some time between 2 and 4 where C prime of t equals 2 by the mean value theorem since the function is differentiable. Use a midpoint sum to approximate this. Explain the meaning of this. This is average C. 1 over b minus a. Integral from a to b of something is the average something. I'm just going to say that right now. This is the average amount of coffee in the cup. What is it in? Ounces. It's the average C. C is in ounces. This is in ounces. The midpoint Riemann sum. 3 subintervals. That means from 0 to 6, we'll need to go from 0 to 2. That base length's 2. You will use the height in the middle. 2 to 4, the base length's 2. Height is 11.2. 4 to 6, the base length's 2. Use the middle height that. So the approximation is 1/6, 2 times 5.3 plus 2 times 11.2 plus 2 times 13.8. Boom. Okay. And then part D, the amount of coffee in the cup is modeled by B. Using this model, find the rate at which the amount of coffee is changing when t equals 5. If this is the amount of coffee, what's the rate at which the amount of coffee is changing? You take the derivative, the rate of change of the total. B prime. Now, this is a no calculator problem, so you got to do this by hand. You'd have an O and an I. The O is negative 16 e to the power. The I is the negative 0.4 t. So the derivative is negative 16 e to the power times negative 0.4. Negative 16 e to the negative 0.4 t times negative 0.4 b prime of 5. You can leave it like this. Negative 16 e to the negative 0.4 times 5 times negative 0.4. That is fine. All right, 2013, let's look at these scoring guidelines. This is question number 3. 1.6 ounces per minute. 1.6 ounces per minute. 2 points. Boom. Found the slope. Used mean value theorem. Talking about the function's differentiable. Okay. Boom. I don't want to know why they say it's differentiable, therefore it's continuous. Just say differentiable. If it's differentiable, that implies continuity. You don't have to say it's differentiable and continuous. It's just different. Differentiable means it's continuous. 1/6, 2 times 5.3, 2 times 11.2, 2 times 13.8. Boom, done. This, negative 16 times negative 0.4 e to the negative 0.4 times 5. They would accept this because it's a no calculator question. A lot of people just freak out. It's like, I hate not using a calculator. It's no big deal. Okay? All right. I'm going to remove the rest of the questions, like the 2012 one, because that's enough, man. 1, 2, 3, 4, 5, 6, 7. Yeah, we'll call it that. We'll be able to get a lot of them in class. All right, that's tables.